Okay, so as I was saying, so let's continue. So you can see we can index that with this. For example, this one is indexing from position 1 to 4 to 4. So 4 means minus 3. 3 to return 3 now. So 1, 2, 3 to this, right? So you can also do position 1, which is from this to minus 1. So that means it will remove 1 from it. So it will, instead of stopping here, to stop here, right? So the one other thing I want to explain is now you can, if you don't put, so for example, let's do another list, LST, and have a sub list in it. So let's say you have 3, 4, 5. Then again, you now have another list inside the 3, 6, 4, comma. Then you have maybe another test. You know, you can use single quote or right, and then maybe we have 1 billion, right? Now, as this is, if I just say LST and I didn't write anything inside, so if I just put this sign, I'm saying give me everything. So that's what that means, right? And that's the column. Now let's say I want to retrieve this one now. You know, remember in this bigger list you have this position 1, 0, 1, 2, 3, 4, 5. 0, 1, 2, 3. So this is position 3, and I want to access 6. So this is position. This list is in position 3, and 6 is in position what? 1 of this list. So I want to access this now. I will just say LST position 3, and then the sublist I want to access position 1. So if I do this now, this will return 6 for me. You can see. So that's how you do sublist. So this again can still have, let's say it has another sub, you still do another sub. That's how you rank your list. All right. Let me close this. So and then as you can see, note the difference between the two lines for mutability. List 2 equals to list 1. So 2 independent copies, 2 reference. So what this is just saying is that I can create another name, list 2, that now houses list 1, right? Which is still called, just like what I said the other time, that I can say LST. So instead of calling LST, like LSTS, for example, or LSE equals to LST. So I can now say again, print LSC. So it's just like assigning what I have for LST to LSC, which is to call it so reassignment, right? Then we have the in operator and the not in operator, right? So this is just to tell us to affirm. So I can have a list and I say, okay, and just I want to check, right? I want to check from this list. I want to say check LSC. Let's say check if R in LSC. Oh, sorry, I said check if 5. So you can see saying true, right? Because there is 5 here, right? I can say check if 7 in LSC, it will say false because there is no 7 there, right? So the in operator, so check if 7 not in LSC, it will say true, right? So this will be very useful because 7 is not, this is very, very useful when you are doing your control flow statements. When you're talking about control flow, you're talking about, we talk about it anyway, the for loop, the while loop, and the if, right? The if statement usually. All right, so that's that about that. So let's get back to what we have. So you can see A in ABCDE. You know, I told you can also index what's it called? Index tests, as well as you can index lists, right? But the major difference is lists are what? Mutable, while tests and tuples are not mutable, right? Now, someone want to ask me, what are the usability, right? It depends on what you want to achieve. If I want to achieve in a case where I want to input an ID, right? I want to input a set of ID. I don't want that ID to change. In that case, I will use a tuple because I know tuples are immutable, right? So I will use a tuple. But if I need something that I want to update very frequently, I can go for a list because I know I can always make changes, right? Anytime I want to. So these are some of the use cases of list and tuples. Then this is the plus operator. So meaning you can also add there. So let me just talk about some other operations you can do with the list, with the tuples, and the rest of them, right? So there are some operations you can do. You can append operations that can be done on a list. Or let me just see on list. On list. All right. So for a list, you can append to a list. You can remove from a list. You can extend a list. You can pop a list. And a whole lot of them. So many others. So we'll look at these ones. All right. So you can append, you can remove, you can extend, you can pop, right? And a lot of other things that you can do. Of course, as well, you can also perform some operations on list. All right. You can add to a list like addition. You can do a addition operation. You can get the length of a list, right? You can get the minimum, you can get the maximum. So let's try these guys out with an example. So let's say, for example, we have a list LST. So I can say LST, let me add, remember we have one other list here, which is LIST underscore. I can do an addition. I can say LST plus LIST underscore to add both together. You can see. So it has added it. You discover that the first one, which is this LST, stopped at true, and then it added the other one. So you can add it, right? I can also have a list like, let's say I have A is a list, for example, and it contains 2, 4, 6, 8. I can perform these operations, append, remove, extend on this, right? I can say A dot. So let me now name this new guy now. Let me name it B. So I can say B equals to A dot extend, or let me start append. Append. So append means add something to it. I can say append 9 to this list. You know, it's 2, 4, 6, let me say 10. 2, 4, 6, 8, 10. So append 10 to it. So if I run this and I say print B, for example, so this does add 10. Print A. So print A. So you can see that A now has what? 10. So I've appended 10 to A. So A dot append 10, right? So if I want to append more than 2 things, right, I can use append extend. So if I want to append more than 2 things, so I will use the word extend. So I can say A dot extend, and then you can see I can put it in a list. I say extend it with what? With, let's say 3, 5, 7. If I say print A now, you see that it's now longer, right? You can see that it has added 3, 5, 7 to A. So I can extend. I can also say, okay, I want to remove 5. I can say A dot remove the first one. Remove 2, right? So that way it will remove. So if I say print A, it will remove A now. You can see it have removed 2. I can also do it as I did, like the A dot remove. So instead of placing the particular letter, I can put the position. What is the position of, let's say, 10, for example? Position of 10 is 0, 1, 2, 3. So I can say remove letter in position 3. All right. So if I run print A now, it will have removed 10. All right. You can see it has removed 10. So I can specify the position as well. Right. So I can also pop, right? So popping, all right, is more of addition as well. So as I was saying, pop is used to remove, right? But now remember, when you are removing this, you are specifying, which I specified, I had to put A into bracket the position. But if I'm to use pop, right, I don't need to specify the position. I don't need to specify the list name again. I will just specify the position I want to remove. Let's say this one now. Let me remove position 1. All right, A dot pop 1. All right, so position of that is 6, right? 6 is in position 1. If I print A now, you can see that there is no more 6 there. All right, so I'm removing by position. So you can use remove, you can use pop as well, right? So like I said, you can also perform addition of lists, right? Which I think I've done that, right? Okay, we've done that. So I can do A plus LST. So I can add them together. All right, I think we've done that. So it adds them. So I can also get the minimum of A, or the length. So I can say print the length of A. Remember, A now is now 48357. So what's the length of this A now? It will print it to say it's now 5, right? I can say, okay, give me the minimum or the maximum mean of A. All right, you can see it's 3. That's the minimum. The maximum here is 8, right? So I say print max. It returns the maximum as well. So these are basically the functions you can do with list. This also applies to tuple, right? So except that tuples are what? Not mutable, right? Let's proceed so fast. So of course, these other operations you can do with a list. You can multiply every values of the list times. You can multiply it. So if I multiply this now, I'm saying duplicate it 3 times. That is the meaning of this times 3 here. 1, 2, 3, 1, 2, 3, 1, 2, 3. All right. You can see what you can do that for a tuple, and you can do that for a list as well. The star operator is a new tuple list string that replaces the original. So we do times 3 of this as well. It does the same thing, and the same thing for string. So it applies to all. So I have a string that is, let's say, eagle. So if I do A times 3, it says eagle, right? So if I say, if I have a list as well or a tuple, it does the same thing. That's what that is saying. So tuple versus list. So immutability, you can see, look at this for a tuple. 23 ABC 4.5 says 2 by 3 and then. So position 2 here is 0, 1, 2. 0, 1, 2. I should be returning this. Okay, sorry. So we want to assign to position 2, 0, 1, 2. Position 2 is 4.56. But remember, look at what he said. When we wanted to assign, we want to change the value. What is it say? Object doesn't support item assignment. So because it's a tuple. Remember, tuple, you recognize that by the normal curve bracket, right? so you can't change it. But remember when we were doing for a list, we were able to change. So for example, our A now, I can say A, position A. A is 48357. I want to change that one in position 2. So 0, 1, 2. Position 2 is 3. Right? So I want to change it to, I think we reduced it. Okay, still 5 here. Position 2, I want to change it to, let's say 7. Instantly, if I say print A. Oh, sorry, we reassigned A. So you can see, so that's why it's saying string, right? We reassigned A. So, but I can also change this one as well. So you remember strings strings cannot be changed, remember. So let's do another, it's immutable as well. Another one that's 2, 4, 6. This is a list, right? So if I say B, change the one in position 1 and the last one, change them to 7 plus, change them to 7, 9. So it changes this because it's a list, right? So if I say print B now, so you can see that's changed to 4 and 6 to what? 7 and 9. But you can't do that if this B now were to be a tuple or a string. You cannot write it through an error. So that's what this is. You can't change. You can't change the tuple. You can make a fresh tuple and assign it responsive previously. So what you can do is what you have here, right? You can just do a reassignment. Or what you can do is you want to change the tuple. First of all, change it to a list and then change it back to a tuple. Now look at what I'm saying. So this B now, we have B. I can change B to a tuple by saying tuple B. So you can see, what can you see? You can see that B, which was normally a bracket 279, I've changed it to what? A tuple, and the bracket has changed. So in case I want to change this tuple now, B is now a tuple. If I say print B, B is now a tuple, right? And I want to change the value inside it. All I need to do is just to say, I can do everything together in one line and say, change it to list. How do I change it to list? Just write list and then write the name of the tuple, which is B. You've changed it to list with this now. So if you print it now, you see that it has changed. So you can now do a remover or appending on this now. You can append on this now and say, okay, append 8 or 7. So this one runs now. The tuple already has no attribute append. We've changed it now. Okay, so we didn't assign it. So we have to assign it, right? We have to assign, or we can do list B. List B dot append from here and append 7 because we've changed it there. So if you say print B now, it won't still work because we have to assign. So what this is saying is we are just printing it. We have to assign it first. We have to assign it a value. C is equal to, so if we say C now, okay, we didn't run this first. Then print C now. Okay, this is all we'll do. Let's not append yet. So we first of all change the tuple to lists, right? And then let's now append C dot append is 9, for example. So we've done that now. So let's now print. Okay, let's first of all just you have to first of all write it like that, C dot append, and then now print C. So it will have appended 9 now. You can see 9 is now appended. We did it twice. All right. So that's how that works, right? So I've talked about this append, insert. So you can append, you can insert. For insert, it takes two arguments: the position you want to insert to and what you want to insert. For example, we are inserting into the list. We are inserting into position 2, 0, 1, 2. So we are inserting here. So to insert 2 here, you see 0, 1, 2. It has inserted high there. So you can extend. I've talked about extend method. So you can extend with a particular list, right? You can use index as well, li.index of b. So instead of saying, now this is like a reverse. Remember, we want to, for this C now, I can say C and say, okay, position 2. What is in position 2? Position 2, 0, 1, 2, that's 6, right? So if I want to, instead of putting this position, I want to know the position of this 6. I don't know that it's 2. I can use what C dot index. Index of for 6. What is the position of 6? That's what that means. You can see it's returning what 6. What is the position of 2? For example, to say use 0, right? You can say 0. So that's how you can do. I've told us you can do a count, you can do a len, which is what you have here, right? Reverse, you can do a sort as well. So to arrange, right? Which is very, very, very important. So you can sort, you can reverse. Reverse is just to start from. So for example, like this our C now, I can say C dot reverse. So we have print C now. Should have check that. Supposed to have reversed it. Okay, let's print C first. So be sure. Okay, this is C. So C is equal to C dot reverse. Okay, now let's print C. So that was supposed to reverse C now. I'm maintaining this spelling. Okay, let me do a sort. Let's see. Okay, let me print C first. Okay, C is no longer having any value. So let's just 3, 7, 4, 7, 6. So let's print C. I think we've not round this. Oh, we didn't round this the other time. C. Yes, so C dot reverse now. Let's run this. So reverse this now. Let's print C now. It should now be reversed. Still not reversing. So okay, C dot count. Count. So normally it should be len and do len of C. Yes, 5. Oh, why is reverse not working? All right, so okay, so it's done now. That's reversed it. So you can see it as well. It's now starting from 6, 7. So I can also say C dot sort around that. Then let's call C again. Then it will have sorted it, right? I see 3, 4, 5, 6, 7, right? Now I will talk about user-defined functions later. List slower, more than powerful, slower but more powerful than tuples, right? This can be modified lots and have lots of handy operations that can perform tables. I've talked about this conversion. You can list to tuple, tuple to list. You can do a lot of conversions, right? So let's talk about dictionaries, right? Dictionaries store a mapping between the set of keys and the value. So keys can be very immutable type, values can be any type. A single dictionary can store values of different types. You can divide, modify, view, look up, delete the key value pairs in a dictionary, right? These are a dictionary looks like. Now, you can see what you have. D, a dictionary always starts with curly brackets. Please note it. Dictionary starts with a curly bracket, right? So when you see that, a dictionary and a list, both of them start with curly brackets. So whenever you see this kind of bracket, you know, is either you're talking about a set or a dictionary. So we'll still take some few examples on each of these when we go to our exercise that do. All right. So you can see it's in key value. So that's what this is what we mean by is in pairs. It can be changed, like what you read here, and it's in key. So user is a key, Buzo is a value, password is a key, PSW is a key, 1, 2, 3, 4 is a value. And you can also do select them. So right. So if I say D, this user key, what is the value? Bozo. Password, what is the value? All right. You can do that, right? But one thing that you cannot do, okay, sorry, innermost one. So one thing that you can also do is reassign, right? To use user, I want to reassign clan for it, right? And if I print it, you can see that it has reassigned user to clan. I can reassign the ID to 45. So this, yeah, this is the assignment. Remember, this ID is not there before. So if I bring in another value that is not in that dictionary, then it will take it as I'm doing an append or an addition to that list. So you can see that ID is not in this dictionary before, but now we've assigned 45 to the value. This key, this value. You can also do a delete. So we'll go back to our Jupyter to iron this up, right? You can also do a delete, right? You can delete, you can see deal user. So here it has deleted the first one, which is this key, using this key. So it's now left with this and this. You can also clear. So when you clear, meaning you removed all, right? So and you have this. So you can get the keys. The keys here are what? You can say d.keys to get the keys, user P and I, values to get this, then items, right? List of all items in tuples. So you can get items, the items, just is the same thing, but it's now converted them into a list of tuples, right? Which is all you have here. So let's proceed and test with something. So let's use a detail of some set of people. So let's say dict. Dict equals to, remember a dictionary start with this, and in the dictionary you always have a key and the value, key and value, key and value, very key. So now let's see. I have a particular set of students, their ID and their name. So I can say ID1. Remember, int does not, so ID1, the name is Mike, comma, ID2, the name is Joe, ID3, the name is Daryl, ID4, the name is Shegu. Now, this is my dictionary, right? Austria. Oh, we are supposed to put, this is a comment. This is not part of the code, so sorry. So now, as I said, I can get the keys. I can say dict.keys to give me all the keys. The keys here are 1, 2, 3, 4. So it runs, and then, so let me print. So you can see dict.keys, you have to put them in bracket 1, 2, 3, 4. I can copy this code and then change them to dict.values. Dict.values, and then it gives the values, right? Remember, I can also delete, I can reassign, I can add, I can say dict and add, maybe I'm adding index 5, ID 5, and I'm giving it the name Alausa, for example. Alausa, for example, all right? So if I call my dict again now, it would have added Alausa, all right? I can say delete, right? Deal, dict, when the ID is 2, right? What does that do? So when I call my dict now, so I'll remove Joe record, right? You can see. And then of course, that thing. Okay, we can also clear. We talked about this. Talk about this. Okay, so we can also reassign, right? And then we can also clear, right? Dict. All right. So dict now will have nothing. Let me call dict. Okay, so let's just call the dict again so that we can implement. All right, dict. All right, so I can say reassign dict with the key 3. Reassign it. Let's, instead of Dari, let's make it Shogo. So with this now, if I call my dict, so I've reassigned 3 with Shogo instead of Shogo. Remember, it's different from when we are reassigning a fresh ID. It's because this ID is present before now, right? So which is that, of course, the dict.item. So you want to see them, your dicts, you want to see them in the form of lists and tuples. So dict.items, and then run it, and then you have it as items. So these are dictionaries, right? We take some examples. All right, so let's try with an example. Let's say um, so let's say I want to enter the detail of a staff using a dictionary, right? I can do that by saying I'll assign the name to that dictionary. Let's say FFX equals to. So remember, you start with this bracket. I want to enter the ID. The ID of that person, let's say, is 1. Don't forget, ID is string, so you have to use string. The ID, let's say I want to enter the name. Name will be Mike. Let's say I want to enter his salary. Salary is also a string. Salary, but now the salary is, so let me say 30 US dollars, 30,000 US dollars. Then maybe department, right? IT. So all these ones are all, you can see the ones, so I can use this and then run this. If I call FFS, remember, and I run it, easy, I can see FFS.keys. Remember, I will get all the keys, the ID, the name. If I say FFS values, I will have all the values, the name, and all that. If I say FFS.items, it will convert to a list of tuples. So if I say delete from FFS, where the this is 1, 2, 3 now. So the salary now, the keys. No, you have to use the keys. So salary, for example. And then I say FFS, it has deleted the salary from that list. I can also say FFS clear, and it will clear everything, right? If I say FFS now, there's nothing there again. So these are a list work, right? A list. So I want us to talk about set before we close for this session. So sets is just like what you have, what you know in mathematics. So set, you can do a union, you can do an intersection. You can also convert sets, conversion. So you can convert sets to list, to tuple, anything. And then of course, set also are they are also immutable. All right, and you can do difference of a set. And do difference of a set. So you can do union using let me put the sign ampersand, right? You can do intersection using and. Can convert, you can do a lot of things. And of course, I told you sets are represented using this curly bracket as well, just like you have it in mathematics, right? So let's say we have a set called CB. So the set is of this list 3, 4, 5, 7. We have a set AB 4, 7, 5, 4. So for these two sets, I can say I want to, let's say D is the intersection. Remember intersection, or let's start with union. CB union AB. And then let me print D. Oh, sorry, I was supposed to comment this out. This. So you can see it has done a union. 3, 4, 5, 7 is in both, 7, 3, 4, 5, 4 is in both, so 5, 7, 8. So I've done a union. So I change this, I copy this code. I can change this to hand, and that will do an intersection, right? What is common to both is 5 and 7. It has done an intersection. Instead of this, instead of using this sign, I can change this. Instead of using this sign for union, I can say dot union, and then I put second one in brackets. You're still going to get the same answer. I can also say, instead of using and for intersection, I can say dot intersect. Dot intersect. So that's not okay. Sorry, intersection. You can see, and you get intersection. I can also say the difference. I can say minus CB minus AB. So CB minus AB, now we look at what is the difference. 5 and 7 are in both. CB minus AB is 3 and 8 in this case, right? 3 and 8. But if I change it now and say AB minus, and say AB minus CB. So in that case, what you to consider AB first. What are the difference here? What are the same thing here? 5 and 7. What is different? 4 is not. 4 is the difference here. So it turns out 4 for you, right? Instead of using that minus, you can also use what? You can also say CB dot difference. And then you still have the same answer based on what you're putting as reference. So, and then I've told us they are immutable. You can do set conversion. I can say this set D, which is, okay, let me say CB. I can say F is equal to list. I just write list, list of CB. So it converts CB. So if I say F now, it converts CB to a list. So you can do a conversion as well. So these are the major trackbacks, right, that we have. Let's go back to here. So we have it. So I've discussed set as well. Set was not discussed the last time we discussed it. So in our next class, we'll talk about the control flows and the functions, right? I hope you gained something. You have a comprehensive assignment as well. So I want to, the task that we have will involve control flow and will involve functions. So that's why I want to treat functions and control flow before we now talk about doing some exercises.